You're welcome to Ekidel.com, where future leaders come to improve their knowledge.
Hi, welcome to Ekidel. My name is Justice Umaka. I am your instructor. Today, we will be learning how to design a part foundation using Protastructure as our design software. Looking at this building right here, this is a one-story residential building. It is a concrete building which we have already designed, run the analysis, and designed here in structure. So for the lesson for today, we will be learning how to design a part foundation. In our coming video, we will show you how to make your choice of foundation, when to make your choice of foundation, and what will prompt you to choose either a part foundation or a raft foundation or a pie foundation or a strip foundation to design for your structure. Okay, so I will urge you to subscribe so that you can see more of our video. So for today, we will be learning how to design this kind of foundation, and this kind of foundation is called a pie foundation. So just to dive in, looking at this structure, here, so this has a cantilever. You can see the cantilever of 600 left and right. So it's really quite a good structure. So also, if you want to learn how to input your cantilever loads, I'll say you should also check our previous video. We have done a lot of video on how to insert cantilever slab and also input a cantilever load on the slab. Okay, so let's get started on our deal for today, which is to design the part foundation. So to start your foundation design, you go to story 00. So you double click on story 00. Now, before you must start your foundation design, you must make sure that your building have been analyzed and also designed before you can now start your foundation design. For this purpose, we have already done our building analysis and design for this structure. You can check our previous video to see that. So to start your foundation design, your part foundation design, you click on story 00, double click, and then you click on one of the columns or highlight one of the columns, and then right click, and then you click insert part base. Now a dialog box appears which shows you your parameters, soil parameters, and your footing parameters. Now on this area, this is telling you the footing level. So the footing level shows that it will take the name of the column, as this is column 21. So this is also showing us as footing 21. So but you can choose to change it to any kind of name you want. Maybe you want to say part 1 or footing 1. Footing 1, you can choose to do that too, to say footing 1. Okay, then the next thing right now is to input your footing depth. This is your part. I will take I will choose 350. Minimum depth for part foundation that you can use is 200. So depending on the kind of building and the kind of load that you have on your structure, minimum footing depth is 200, and the maximum footing depth for a part foundation that is reasonable is 500. Once your foundation depth, which is the part foundation, exceeds 500, it is advisable to move to the next type of foundation, either strip or raft foundation, because at that stage, when it is up to 500, it is no longer economical to use a part foundation. Then the next thing right now you have to input. So we choose our footing depth as 350. The next thing you input again is tappard height. This can be gotten from, okay, let's leave this place at 0, because we don't want our footing to be tapered like in a step shape. So we don't want a step shape. We want our footing to be in a rectangular shape. So we leave this tapered height as 0. The next thing you see here is your surge charge height. This surge charge height simply means the soil on top of the foundation. What this is the height of the soil from the ground floor down to the top of the foundation. So I'll just leave this as default 700. Then the next thing you see right now is your footing eccentricity, which is at x and as y. So if you want your footing to be centralized on your column, you just leave this as 0 at 0. Otherwise, you input a value. But I would advise you just leave it as 0, except maybe there is an obstruction, or there is an obstacle, or another kind of foundation, or anything that is trying to overlap or collide with your foundation. That is when you can now input your eccentricity to at least shift the part foundation off or a bit off from that obstacle. The next thing right now you see here is your soil unit weight. Soil unit weight can be gotten from your soil test. So I'll just choose 19. I'll choose 18. Sorry, it ranges from 18 to 20 depending on the kind of soil. So the next thing you see right here is your allowable stress of soil, which simply means the bearing capacity of the soil. So the bearing capacity in this case, because this is a project for engineer moorings, and which I have already completed, but I just used as let me use it to teach for part foundation lesson. So in my mooring case, my bearing capacity or allowable stress of soil is 150. Bars for the foundation design. So I will quickly choose 12, and I'll also choose 12. You click on square footing because you want it to be a square footing. If you want it to be a rectangular footing, you just uncheck this and then begin to adjust these values. You can see it's becoming a rectangular footing, but we want a square footing, so just say square. The next thing right now you do that is very important is for you to check for punching. You check for punching if the depth that you inputted, which is the 400, this 350 that we inputted, is very small, it's not adequate to carry the load coming on this column, you're seeing here, then the punching check here will fail because the load on the column, which is the axial load, is trying to punch through the footing. So for you to resist that punching, you have to increase your footing depth. So for now, our punching check at the face of the column is okay, which is nice. And at 1.5D from the face of the column is also okay. So this must be okay, this must be okay, and this must be okay. Then the next thing again, you check for moment. Moment here must be okay, this must be okay, this must be okay. And at the Y direction, you must have okay, okay, and okay. So once you've checked for your punching check and you've checked for your shear, and they are all okay, this tray must be okay, here must be okay, and this place must be okay. And the next thing you do, right, you check is your reinforcement. So we have our reinforcement. AS provided, AS required to be 700 millimeters square per meter. And then what we supplied based on what we inputted here is 753, which is more than what is required, so it is okay. So in that case now, our foundation reinforcement is given us as diameter 12 at spacing of 150. So once you have done checking all this and the punching check is okay, the shear check is okay on the X and Y axis, then you click on OK. Then you click on final OK. So with this now, you have done your first part foundation design. Let's go and check it out on 3D view. So you can see it closely right here that you have done your first part foundation. So this is the part foundation. Sorry. So this is your part foundation that we have just designed for. So we go back to our 3D view, our plan view, to continue for the next. Now you click again the next, right click and say insert part base. Now at this stage right now, once you're done, once you have done setting, inputting all these parameters for the first time, you will not input anything again. The next thing you go for is just to be calculating. So you go calculate to design your foundation, square it, and then check for your punching check if it's okay, check for this if it's okay, and check for this if it's okay. In this case, they are all okay. So I can now say that the foundation is okay. And I'll say okay. Then I'll go again. You go again for the next. Right click and say insert part base, calculate, square it, and then we say you check again for if the punching check is okay. Make sure you check this because it's very important so that you know if the depth of the foundation is not adequate for one particular column or not. You say okay and say okay. Then the next thing again you do right now. Now let's try to design because we have been designing for a square footing. Let's try to design for a rectangular footing. Let's choose this column for that. So you highlight this column and right click and say insert part base, and then you calculate. At this point now, we will not have to square it again. So because we want to design for a rectangular footing, so we will now want to design for that. So let's say 1.5 by 1.2. Okay, 1.5 by 1 meter. Let's use that. Okay, so this is now 1.5 by 1 meter. Then you check again for your punching, which is okay. You check again for your shear, check, which is okay, and for your shear is okay. Then you now say okay and okay. So this is now our rectangular footing. As you can see it here, 1.5 meter times 1 meter. If you check it on 3D view again, you will see the shape that this is a square. This is a rectangular footing. Why this is a square footing. Okay, let's go again. Now, to save the stress for all, to save the stress of doing each of these column part base individually, you can choose to highlight some set of column, right click and say insert part base. They will ask you to create a typical footing for the selected column. Just say no so that it can design each of these columns individually and not to create a typical footing. So you just uncheck that and say okay. And then you wait for it to insert. You wait for it to insert. I don't really like doing this in a live project, in a real project, because you will not know if the punching and the shear check is okay. But for a real project, I would advise you do it individually so that you can check what the load is saying on the footing. You do it individually to know what the load is saying on the footing. Because if you do it, okay, let's check this right now to see if it is adequate. Okay, it is adequate. But sometimes if you highlight all the columns and then design the foundation at once, you will not know if any of this is failing. Okay, let's try to do a situation or a scenario when one of these will fail so that you can know, so that you see how it fails. So I'll just say okay for now, and then let me pick one of these columns to show you a scenario when one of the columns is failing, one of the part base is failing, sorry. So let me change my depth now to be 200, and then I'll calculate. Okay, it's still passing. I'll just say okay. Let me change my bearing capacity. Let me assume that the bearing capacity of this place is very low. Let me take 70, and I'll calculate. It's still okay. Let me go again by saying the bearing capacity is low by minimum is 200. Let me go again. Very bad, sorry. I'll say calculate. Now you can see right now this is failing. It is failing very bad. You can see. So this is what happens when your pointing check fails. That means the load from the column is trying to then with that, right, so that is how a foundation fails. So let's go back to our normal bearing capacity, which is 150, and our normal depth, which is 350. And then we just say calculate. Now you see it says square. Okay, so if you didn't square, okay, square, so you now say okay, okay, and okay. But this is not working fine. This is 50 spacing, which is not okay. Let's just, maybe that's what we just did right now have affected the input. Let's just do it back and everything is okay, right? Okay, so we just calculate. Okay, so at this point right now we have checked this is okay, we check this is okay, and this is okay, and our this is also okay. Then we say final okay, and then final okay. So knowing that right now, knowing that you must have to design for the foundation individually and not a group one. But for the base of this tutorial, just to make it faster, I'll just click highlight all my columns and then highlight all my columns and then design them at once. But for a live project, if you're doing for a client, never you do this. Do it individually. Okay, I'll now say input part base. Hold on to wait for while the part base is being inserted. Okay. So in our next video, we will be teaching how to design a strip foundation. Most people have been asking how do we design a strip foundation. So we will be teaching how to design a strip foundation, and then we move on to raft foundation, and then we move on to the final one, which is the pie foundation. So I'd like you to subscribe while you wait for these videos to come. Okay, it's almost done inserting all the part base. It's almost done remaining this and this. Okay, let's do this again. Let's insert this, click and then insert part base, calculate, square it. So check our checking. They are all okay, and the spacing is okay. Then okay, and then okay. Okay, it designed this to be a rectangular footing. Let's see why it did that. So just check again, calculate, and then let's say square footing. What's happened? Okay, this is okay, this is okay, this is okay. It's taking 1.6 by 1.6 for a square footing. Is it adequate? Say okay, and then we say okay. For this, for me, it's very big. You can also choose to decrease the part foundation on this area, on that's the size, because most times this prota program uses the moment to size your foundation, which is not how it is. The normal way to do that is to use the axial load to size the foundation. So if you divide this axial load that you have right here all over the bearing capacity, so the axial load all over the bearing capacity gives you the size of your foundation. So in this case, this program Prota is trying to use this moment. So if I choose use manually defined load, I will make my moment to be 0 and make this to be 0, and then get the actual size. You can now see that we are having 1 meter by 1 meter, not 1.6 by 1.6, and everything is still okay. So we can now say okay and okay. This will be an advanced part foundation design, which I will teach later. But for now, this is how we design our part foundation. So let's go back and check the 3D view of how it looks like. So this is how we now design our part foundation. This is to make it clearer. I'll just off the grid. So this is how we design, turn off the grid, sorry, our part foundation. You can see that. You can see that. You can see that. I choose this color. I like the color very well, so I have to reset my prota colors to match my my color preference. You can see that. You can see. Okay, so thank you for watching. I would like you to subscribe and then wait for our next video. Always try to recommend your friends to also come and learn more about civil engineering and structural engineering. Thank you. We love you.